Good morning. Okay, so today's lesson builds on last lesson, which was all about procedures. So we said a procedure is a named section of code, as in a bit of code with a name, which makes our code easier to understand because instead of writing 10 lines to draw a shape, you can give that section a name and say draw star. So you can define in Python, telling Python how to draw a star, and then you can call that function, that procedure as many times as you like just by saying draw star, draw star, draw star. Today we're talking about functions which are very similar to procedures, but with one key difference. We want to know what a function is. We want to know what a parameter is. We want to know what a return value is. We want to be able to use functions and make our own functions. So we've talked about procedures already. Blocks of code that have a name that you can reuse as much as you like. They're a really good example of abstraction. So abstraction is hiding unnecessary detail to focus on the most important thing. As in, we hide how a procedure works to focus on the most important thing, which is what it actually does. And we're going to build on that by talking about functions. So a function is a subprogram. Remember, a procedure is a subprogram. What's a subprogram? It's a part of a program. They're very similar to procedures, as in they're both defined using def. They both have a name. They can both have parameters. The only difference is that a function always returns a value and a procedure never returns a value. What does that mean? It means when you do something in a function, if there's an end result or a calculation or a thing that you want to send back, the return value is the thing that you send back. So have a look. So as an example, we wanted to find the biggest. So let's say find the biggest. And we'd have a parameter with a list of numbers, and we want to say the biggest number in that list is, and then the biggest number. Okay. So for example, if we want to say find the biggest, let's not put it in print at the moment. Let's just say find the biggest number out of 1, 2, 3, 4, 5, 6, 7. We hope that it will find the biggest number. So at the moment, when we call it, we've got a syntax error because on line 2, I want the colon to be in there and then a comma. There we go. It doesn't know what the biggest is because we haven't actually done the calculation yet. Let's see. Biggest equals the maximum number in that list. Will that work? There we go. The biggest number in that list is 7. And even if it's not at the end, it will find that value. Now, we want to know, is this a procedure or a function? We said the difference is a procedure is something with a name that we can define, that we can call as many times as we like that. So we're calling it twice now. But a function returns a value. So what do we mean by return a value? Well, we should be able to do something like biggest equals and then print the biggest. Can you see here that this is being displayed here? I'm going to comment that out. So all that's being displayed now is this, print biggest. Well, what is biggest? Biggest is the value we get back from this. And here we've got nothing back. This is a procedure because it doesn't return anything. If we tell this function to return something and we say return the biggest number, then it now passes that value back. It says work out what the biggest number is, pass it back to the thing that called us, so that instead of doing all this, we can say find the return value and store it there. So that's the return value. So at the moment, it doesn't return a value. It's a procedure. Now, as soon as it returns something, it's a function. That is the only difference. Back to the slides, please. Here we go. So example is, this is a built-in function. You ask a question, the answer to the question is returned and stored in there. You've come across that before. It's a built-in function. Float is a function because you take a string and you convert it to a floating point number and you store the result here. The return value of float is the float value of that string. Or same for integer. Int is a built-in function. It has one parameter. It converts the parameter to an int. The return value is the integer version of that string, and you store that there. And there's others. You can find the length of a parameter. You can convert a string to alphanumeric. Sorry, you can check and see if something is just letters. You can convert something to lowercase. They're all functions. We've talked about that already. Rather than using built-in ones, we can define our own. So say, for example, at the moment, VAT is 20%, which is 0.2 as a decimal. We can say add VAT to a certain amount, and we say the total is going to be whatever we would be charged without VAT, plus the total times by VAT, and then we return that here. So if we say add VAT to our subtotal of £34.99, it will work out the VAT, add it to the bill, and display it. That's how you can define your own functions. Don't worry too much about the maths involved. The important thing is you define a new function. It can have some inputs, some parameters. It must return a value. There we go. So this is calling the function. This is defining the function. This is returning the value. We'll come back to that later in the lesson. I think it's important at this point just to open up CT16 activities. Your job is to say, does it return a value or not? So input is a function because it returns a value. Len is a function because it returns the length of the string. Print is a procedure because it doesn't return anything. How do I mean by it doesn't return anything? Let's have a look. Print hello. It says something, but if I say the return value is equal to something, and then I display the return value, that second one, oh, what have I done wrong here? Return value. It is defined, isn't it? Have I spelled that the same? Weird, because print just doesn't return anything. It doesn't have a return value. So yeah, say if it's procedure or function, and then tell me what is actually returned. I'll give you your screens back just now. So a couple of you are asking how you can test these. Let's take this one, CHR65. If you type it into the interpreter in Thonny, the interpreter allows you to run one line of code at a time rather than writing out a whole program. So you can just put one line of code in, and if you get a result, then it is a function. If it's something that is just a procedure, then you don't get a return value. So for example, this CHR65 converts a number into the character, CHR for character, converting that number using ASCII, American Standard Code for Information Interchange. So let's go through activity 2, because you do get some questions in your paper 2 where you get some code with all of the right lines, but you've just got to copy and paste them in the right order. So you just try and run it, you get all sorts of error messages. We'll start with these sections. So you always import first, then you define your global variables. So you import your libraries first, then you have your global variables. That's the variables that you can access from any part of your program. Then you've got your subprograms, your procedures and your functions, and then your main programs. So first things first, we can find anything that says import and put them at the top. So is there anything else we need to import? No. So that says to Python how you can do random numbers. Then we want any of the subprograms, definitions, as they're the easiest ones to find next. So any definitions, they're going to go in here. And anything that says return, they're going to go in here. Right, what on earth is this supposed to do? Is a rebel or is polyhedra dice? We should probably read and see what it's supposed to be doing. Program simulates the roll of a dice, but the user can determine the number of sides, and these are called polyhedras. The lines of code below are all jumbled up. One way to tackle this would be to cut the lines apart and arrange them on the keyboard. Interesting. So a polyhedra dice would presumably return a roll, and then you can check and see if it's a rebel one. When is it a rebel dice? What on earth is that all about? Doesn't explain it at all, does it? You're a dice rebel, but I'll roll that dice for you. It's not very clear. Well, we'll see. Presumably there's some logic in here of working out if it's a rebel. Right. So how can we do this? Let's see. I think this looks like something that will work out roll. So I'm going to plop that inside the polyhedra dice, because we're going to say make a new local variable, a variable that only exists for this subprogram, and set it to a random number between 1 and this parameter. What's a parameter? It's a value that you get passed as an input. So now we should be able to use polyhedra dice. So here we're calling that function. We're saying my roll is equal to the return value from here. And in order to do that, we need to know what num sides is. So where do we have a line that says what num sides is? Well, here we do. Control X to cut. That has to go above here because we need to know how many sides there are on the dice. Right, what have we got now? So I suppose we've got some logic here to say, is it a rebel dice for the number of sides? If it is, we're going to say you're a dice rebel. What on earth that means. People's life ambition to be a dice rebel. Then we can have else. So if we're not a dice rebel, we can say you're a bit conservative. Is that a political statement? Don't know. But you can still have a roll. And then maybe only after we've said they're a rebel or conservative do we display the result. So that looks like this one. You're showing how many number of sides there are, and you're showing what the actual roll is. We're getting somewhere. We've only got a few more to go. So I guess this logic here is whether or not you're a dice rebel or not. So I'll plop that inside this function. If the number of sides is less than 4, or the number of sides is more than 8, then status is true. I guess that means you are a dice rebel. Otherwise, well, there is no else here. I'm not allowed to add anything else in these questions. So let's say status is false to begin with. But if we choose a dice with less than 4 sides or more than 8 sides, we say status is true, and then we return that value. Be careful here, that will only return it if you're a rebel, and a function should always return a value, so it should be lined up there. All right, getting there. Now we just have some global variables left. That's good. Not strictly necessary here. So yes, we just cut those global variables and we're initializing the values in here. So things to highlight that weren't strictly necessary. In Python, you don't need to do this, but in Edexcel, GCSE Computer Science, they always really like it. If you've got a global variable down here you're going to use for your program, you initialize it at the start. What else is not necessary? Well, it's not necessary in Python to have brackets around the thing that you return. But I have seen something in a mark scheme that only gives you a mark if you wrap the return value in brackets. So get into the habit of doing that, please. I hate it. It's horrible. It's not necessary in Python. But I want you to get the marks as well as understanding how to do it properly. So let's see if it works. I'm going to be a dice rebel. A dice with 1 side. There we go. It's not particularly rebellious because we always get a 1. Let's try again. 100. Nice. How about 6? And it works. Okay, so we're going to go through the same code, but this time in Python. Let's just, in Thonny, and check that it works. How many sides on your die? I'll go for 100. And yeah, we've got 100 sides, and it's rolled 76. The reason we're showing you in Thonny is I want you to know what breakpoints are and how to step through things. Remember, a breakpoint is a point in your program that you can pause it to see what's happening. So you can click in the gutter or double click sometimes to add a little red blob. That means when you run it, it should pause at that point, but it didn't because I pressed run and not debug. The debug one means when I run it this time, it will get to this point and it will stop so that we can see inside all of the variables and see that number of sides is 100. Also, really importantly, when you've debugged and you've got a breakpoint, you can use these, step over and step into. Step over will run a whole line, so I've just run that function and stored the return value into my roll 60. But what you can also do is step into, and let me show you how powerful that is. Oops, I don't want to run, I want to debug. So debug, here we go, I'll do 100. We've got the breakpoint. This time I'm going to press F6 to step into. Sorry, F7 to step into. So I love Thonny because it shows you really clearly what's happening. I'm trying to set my roll. Before I can do that, I need to call this function. Before I can call the function, I need to know what the parameter is. So what is num sides? I know that num sides is 100 because I typed that in. So we pop 100 in there. And then we call this function. I just keep pressing F7. So I've now gone to that function and I say roll is going to be random.randint between 1 and p sides. What's p sides? Well, it's the parameter that we were passed. So we've got this whole module here. Oh my goodness. So what is p sides? P sides was 100. We passed in the value 100 as p sides, the parameter. And then we get a number back, in this case 54. That is set to, roll is set to that value, and we can return it. What does return mean? Well, it means send the value back here. So we put that value into my roll over here. So that's what the next question means by how to set breakpoints, and then see the value of each variable. So for activity 3, on mine, I don't have a link here, but some of you say that there is a link on yours. That's nice. If you can't see the codes, you can always get them on the VLE. So we're on half term 3, we're on CT16, and it should be Act 3 students, this one just here. So you should be able to open that in Thonny. Let's have a look. And then it asks you, sorry about the bell, to put a breakpoint on line 16, 17, 9. Oh my goodness, quite a lot of breakpoints. Plop that over there, plop this over here. How do we do breakpoints again? We have to double click. So breakpoint here, breakpoint there, breakpoint there. Well, I can't have a breakpoint on line 19. This is empty. I'll put one on line 20, line 21, line 20. I can't have a breakpoint on a comment, but I can have a breakpoint there. All right, so let's see. So breakpoints only work if you do it on debug. And I want to step through until I get to line 26. Well, I'm ignoring that. I'm going to get to the next one, line 27. You can't have a breakpoint on a comment. So at this point, what is the value of my drink? Well, my drink is empty at the moment. What is the value of drinks? Well, drinks is a list of all of this. So I don't know if there's an extra line in there and it wants you to, if it's got confused by line numbers. Let's see. So run, step over, F6. So if we do it just after that line, then my drink is tea. But I think it should be on that line. The breakpoint will pause execution before it runs. So when you get to that line, my drink is going to be empty, but drinks is going to be a list containing all of these things. Okay. I'm not going to go through activity 4. I'll leave you to work that one out yourself. But at the end of the lesson, I would like this to be uploaded to half term 3, algorithms and programming 3 for me, please. Please remember to save your Word document before you upload. Otherwise, I just get an empty Word document and you get 0 marks.